Hi, and thank you for the introduction, Jack. As you said, my name is Trevor Best. I'm the CEO of Syzygy Plasmonics. I'm going to tell you a little bit about what we do, but first, I need to tell you about the industry that we operate in. So the chemicals industry has been working the same way for the past 100 years. How it works today is first you take a lot of fossil fuel, things like natural gas, and you burn them to produce heat. This heat is used to power an enormous chemical reactor. These chemical reactors are many times the size of this room that we're in. Then the products that are made, things like fertilizer or gasoline, are transported to the point where they're finally consumed by you, the consumer. There's three major problems with this business model. First is carbon emissions. The world is becoming very savvy to the fact of climate change and that carbon emissions are not a sustainable practice. These processes for producing chemicals create gigatons of carbon emissions every single year. The next is cost. There are many technologies that can potentially reduce carbon emissions, but they're simply too expensive. No one will buy gasoline if it is $20 or $30 a gallon. So not only do you have to reduce emissions, you have to do it in a way that is cost effective. And finally, it is centralized production. This model of enormous refineries and chemical manufacturing plants and the large supply chains of distributing to the end consumer is antiquated, very old. Now you see a lot of industries moving towards distributed business models. You see this with 3D printing in manufacturing. You even see it with industries like here at TMCX, medical, where you have people going online now to visit a doctor instead of going to a central hospital. Now I'd like to introduce Syzygy Plasmonics. Our company is building a completely new type of chemical reactor. It is unlike any other chemical reactor on the planet today. It allows us to reduce both the cost and the emissions of chemical production by more than 50%. This reactor is a platform technology, so it can be applied to a very wide variety of chemical reactions. Currently, we have proven it on more than a dozen separate chemical reactions. Now, possibility is great, but as an early stage company, we really need to focus. Our first product will be a small scale, on-site hydrogen production system. This unit will be very small, about the size of a large refrigerator. It will go on the back of industries, things like warehouses, where we'll provide hydrogen for them to do things like operate forklifts or power cells for electricity. Because it is small scale and on-site, it completely eliminates the supply chain associated with hydrogen today. It is very low capex and reduces energy requirements because it's using our reactor, and it is very modular, quick, and easy to deploy. So you're saying hydrogen, that's great. I thought you were talking about chemicals and fuels. Like, why are we excited about hydrogen? That's because hydrogen is a $120 billion industry today, with a B. When you think about hydrogen, there's three segments. First, fuel cell vehicles. This is small today, less than $1 billion, but it is growing very fast. You have a number of companies like Toyota, Honda, Hyundai, all releasing hydrogen fuel cell vehicles. There are a number of 18-wheelers coming out that are powered by hydrogen, and a number of companies are getting into this space. You have small-scale industry. Every piece of metal and glass you see needs hydrogen to be manufactured. Your phones and computers, the semiconductors inside of them, need hydrogen to be manufactured. Food oil, like coffee creamer, and the things that we cook and eat every day, need hydrogen. Have you ever heard of hydrogenated? It is using hydrogen. And finally, large-scale industry. Hydrogen is used in the production of gasoline, fertilizer, and a number of other chemicals. Altogether, these form an enormous market opportunity. So why our system? When I tell you that we can reduce cost, I'm telling you that we can take costs for distributed users from the current price of $6 to $20 per kilogram of hydrogen today down to $3 to $5 per kilogram. Not only are we cutting the cost in half, we also reduce the greenhouse gas emissions associated with the production. Our system is much easier to operate and maintain than existing technology. And finally, we can get this out into the market quicker and at lower capex than our competitors. We already have significant demand. We're getting interest from the fuel cell industries, the industrial gas suppliers, and large energy companies like the ones that are based here in Houston. We recently closed our Series A fundraise. It was Altogether about $9.7 million. We closed that last October, and we are supported by, thank you. We're supported by the Department of Energy's ARPA-E program. This stands for Advanced Research Projects for Energy. They like to fund things like fusion and very advanced technologies, and they've also decided to support us. We've also gotten money from the National Science Foundation for our reaction, where we're actually taking carbon dioxide and turning it back into useful products. How are we able to do this? We're able to do this because we have the world's most stable and active photocatalyst. Because it is a photocatalyst, that means we are using light instead of heat to drive chemical reactions. Because we don't need to operate our reactor at thousands of degrees Fahrenheit, we can do it something more akin to the temperatures at your oven. It dramatically reduces our materials cost. Because we're using light, we can create that light with very high efficiency LEDs powered from renewable electricity, which helps to reduce our carbon footprint. This photocatalyst is many orders of magnitude more active and more stable than any other photocatalyst in history. And it was actually invented right here in Houston at Rice University. So how does our technology work? In the beginning, we make small photocatalytic cells. We combine many of those cells together into a reactor. We put many of those reactors together into a reformer. And finally, those reformers go into the end system. This modular, easy to mass manufacture, massively scalable technology is exactly what is needed to disrupt the chemical and energy industries. And as I mentioned, this is a platform technology, so hydrogen is just the beginning. After hydrogen, we plan on going after carbon dioxide processing, fertilizer, and many more. We are supported by a very talented founding team. Myself, I'm the business side of this. My co-founder, Dr. Suman Kadiwada, he has a PhD in nanomaterials, and he's the one who understands how the reactor works. My also co-founders, Professor Peter Nordlander and Professor Naomi Hollis, are the inventors of the photocatalyst technology that we use, and they're also co-founders in the company. So thank you very much, and I look forward to any questions you may have. So I will take one question really quick, but I wanted to show this pitch. That pitch actually was the pitch that we hit the road with, and whenever I talk about raising $9.7 million, that was the bedrock, the foundation of doing that right there. What was your question really quick?
So what, I guess, sort of like chemical reaction do you use to produce the hydrogen, and how much hydrogen are you able to produce in terms of like, like a production rate per hour or whatever?
Technical questions, great. So we have two different reactions. One, we can make hydrogen from methane. This is the one where we talk about 50% reduction. Traditionally, when you make hydrogen from methane, you have to burn methane to produce heat. And then you make hydrogen from methane. We don't have to burn the methane to produce heat. We can use renewable electricity. That gets us about a 50% reduction in emissions. Our other reaction, this is the one supported by the Department of Energy. We're actually making hydrogen from ammonia. Ammonia is NH3, no carbon molecule, and we can actually achieve zero emission hydrogen through that reaction. But zero emission ammonia is probably not going to be available in the market for about another 5 years, so there's a lot of market considerations with that. On scale up, you asked about production rates. Right now, we're making about, I'm being recorded. We're making about 50,000 times more hydrogen out of our reactor than we were when we first started. So that's a good number. We've managed to scale the technology up pretty dramatically over the past 24 months. So one of the things that I was asked to do today was talk about this pitch and the different parts of it and why the pitch matters. And so intro slide, I don't think needs any explanation. This is just a placeholder while you get up and get your mic ready. But here's where the magic starts. And so what I was actually doing here is this is called the hook. Is you have to get people's attention. And whenever you're raising money or talking about your company, you've really only got about 10 seconds. And in 10 seconds, the people in the audience have decided if they're going to listen to you or if they're going to play with their phones and go to sleep. And so I'm not kidding, it's true. And so pretty much every pitch in the first 10 seconds, everyone in the audience has been like, oh, this is what's up, I want to check this out. Or they're like, this is a good pitch to go to the bathroom and I'll catch the next one after this. And so the hook is very important. And so talking about, something that people aren't necessarily aware of, a little bit of education, telling you about the chemical industry, talking about how this industry is 100 years old and hasn't changed, is usually enough for the people who are interested in the chemicals industry to perk up and go, okay, what is this guy talking about? Then you introduce the problem. So I've got your attention, and now before I start talking about the solution, I'm telling you why. Why is this important? If you guys are familiar with TED Talks, which is a really great one, Simon Sinek, Start With Why. If y'all haven't watched that, I actually recommend everyone go watch that because it's foundational to starting and running a company. Like at the beginning, instead of like, how are you doing this? Like, why are we doing this? And so I'm explaining to you, I've got your attention. Now I'm explaining to you why this matters. Because climate change is a problem. We need technologies that can fight it, but they have to be cost effective. And the current business models are antiquated, and it's time for change. Then I introduce our company. So I've got your attention. I have explained to you the gravity of the situation, and now, boom, here's how we're going to solve it with Syzygy's technology. I give you a little bit of info on the technology and how we work. 50% reduction in cost, 50% reduction in carbon emissions, and so at this point, it's all about feeding information in a way that you don't dig too much into any one thing and people get bored. And now I'm actually just trying to catch and keep your attention for the next 3 or 4 minutes. It's kind of funny, but your whole goal in pitching is you're actually just trying to get one meeting, nothing else. Like after 4 or 5 minutes, y'all know next to nothing about my technology, but you're either interested or you're not. And if you're interested, I was successful. And the PhDs in our lab, they've been working on this stuff for years and years and years. They can run circles around me with how much they know about our technology and how it works. But if I come up here and start talking about how our photocatalyst can use photons to elicit hot electron transfer to different molecular species, like everybody goes to sleep. And so that stuff I think it's really cool, but it's not right for a pitch. So generally I'll try and compact different thoughts to 10 or 15 seconds and then get on to the next thing so that I can hold your attention through the whole pitch. Introduce our product. So this pitch is very geared towards investors. Product is very important. You have to give them an idea of what it is you're selling. If they don't have a good idea of what you do by the end of your pitch, then they probably aren't going to be interested. And so, we've introduced the product, and now that they know what we're making, what are we going to do with it? And so the market opportunity. Depending on how much money you're raising and the kind of business you want to start, it'll change how you want to show the market. Something that I've been counseled on recently is investors now don't get interested unless if you can show a $1 billion market. And now the guys out of Silicon Valley, they're looking for the $1 trillion markets. And so how do we show the potential to get to $1 trillion in disruption? And I know, hundreds of billions, $1 trillion, that sounds so crazy, right? Well, Apple and Amazon have done it. So it's not even unfeasible. It has been done. And so it is absolutely possible. When you talk about our company, we start with hydrogen. Whenever we get later on in the third meeting, we start talking about other chemical reactions, CO2 processing. If we really want to fight climate change, CO2 processing is going to be huge. So we start with hydrogen, then we get into CO2 processing, then we get into fertilizer, then we go after other major chemical reactions, ethylene, which is the basis for all plastics, and boom, you combine all these together and start getting into some other applications, like our reactor can be used in life support systems on spacecraft. And you keep bolting these on, and boom, you can get to $1 trillion market. And so if we are massively successful, it is possible. Challenging, and hey, if I get there, I'll invite all you guys out to my yacht. But incredibly challenging, but not impossible. And the investors want to see that. And so, and it starts here, like a market. And this is reasonable. I can go back to all kinds of market reports that talk about the size of the hydrogen market today. 120 billion today, growing, expected to be 100 billion in the US alone by the end of this decade. Many sources expect the hydrogen market to grow to 2.5 trillion by the end of 2050. So tremendous growth, lots of space to move in. It's very easy for an investor to imagine that if we're successful, we can capture a chunk of that market. That gets them excited, keeps their attention. So now we've talked about the product, the market. Why would people buy this? So we go into our unfair advantage. This is what makes us better than everybody else. At this point, the investors, their mouths start watering, and they're like, "Oh man, I'm really interested in this." You go into this slide. This is very important. This is traction. And so, you can sit up there and talk all day long about your product and the market and all that, but there's, you're up on stage with 20 other investors who are all doing the same thing. And so this slide is incredibly important because traction is outside validation. It's not just me talking, it's other customers, it's, in our case, the Department of Energy, other investors who are coming in and validating this, which gets them even more excited. Finally, now that we've really got their attention, now you can get into the technical stuff. And the technical stuff, because this is probably the densest slide in the whole deck. And this is too heavy to put in the beginning. You'll lose people's attention. And so now that I have firmly gotten people's attention, then I can go through some of the heavier things that'll show them it's not magic. And then once again, this is pretty heavy stuff. Technical description of what we're doing, and this just serves as the skeleton and the muscles behind the product and our unfair advantage. Like, this is how we're building that product. And of course, probably one of the most important slides also in here is the team. Investors value the team highly. They want to see people who are experienced. They want to believe that you have what it takes to get this into the market. And forming a good team is one of the best things you can do for your company. And so we come to the end. One thing I also wanted to add is this pitch is 4 or 5 minutes, and I'm a little out of practice, so I might have gone to about 6 today, but this pitch is meant to get you a first meeting, and once you have that meeting, that pitch has been successful and you never give it again. After this, when we talk about raising, lots and lots of money, we actually did it with this deck, and you will see a lot more detail in this deck. You start talking about like the fuel cell market, like, hey, fuel cells are ready today. Here's what's happened with the fuel cells over the past, decade. You start talking about like, price point, $3 to $5 per kilogram enables a market expansion for fuel cells. At $5, hydrogen fuel cell forklifts become viable for pretty much all warehouses anywhere. At $4 per kilogram, hydrogen hits price parity with diesel. And so if we can get down to below $4 a kilogram, we're actually making hydrogen cheaper than gasoline. And so if you're a fleet operator, you can switch your vehicles from gas to hydrogen and dramatically reduce your carbon footprint and save money every mile you drive. So those notes are very important, but we don't have time for them in the 4-minute pitch. You got to talk about the hydrogen market. Right now the hydrogen market's 91% delivery. The distributed hydrogen market right now, 91% delivered, 10% on-site. And so you see a whole lot more details in this deck. Unit economics. You see, projections. You see, and then we get into the back slides where we get into the extreme details of sensitivities for our costing models. And we don't have time today, but the Excel sheet behind that costing model there is thousands and thousands of cells doing tons of calculations to calculate our unit economics and what happens at each stage of scale up with how do our techno-economic goals impact the performance of our reactor. And see, the thing is now that I'm talking about the really heavy stuff, I see about half of you falling asleep, which is why this pitch, the important one, the first one, is meant to keep you awake. So hey, that was about 30 minutes or so. I'd like to open the floor to any questions You have.
So like, what are your channels? Like, how do you advertise your business?
What are the channels? How do you advertise your business? So we are an early stage company. We're pre-revenue. Right now we're in the process of scaling our technology development. And for us, advertising and channels aren't as important right now. If we establish those and we get everybody ready, and then our technology takes another year to get into the market, all those people are going to be very angry at me. But we've already thought this out. And so we will primarily be pursuing two things, direct sales and partnerships. And so direct sales would be like I work with a large company that builds out hydrogen fueling stations, like some people who are doing this today, Toyota, Shell, Plug Power, like those are three that are building hydrogen fueling stations today. So like working directly with them and selling our equipment directly to those customers. The other would be partnerships. So somebody like an Air Liquide or a Praxair, these guys are huge industrial gas suppliers. They make most of the hydrogen on Earth today. And so partnering with them and saying, hey, you guys already know the whole hydrogen market. You can sell our system and we'll sell through you. And so that's sales through a partnership.
So one thing that wasn't clear was if you're raising $9 million today, how much more will you have to raise before you have a product that you sell? And how long will it take before you actually are generating cash as opposed to raising cash?
That is a great question. And so whenever I was kind of like teasing the much larger, 70 slide deck, that is addressed in there. And so for us, we'll probably need to raise about 10 million more to hit break even. And really, if we want to scale the way I think we can and go globally, we'll probably end up raising about 50 million more. So 10 million hits minor break even, but the manufacturing facilities won't be able to support global rollout with 10 million. If we want to do like a real global rollout, then 50. There's also another question, something that depending on what kind of partnerships we can secure of whether or not equipment sales are the right business model. Equipment sales are a pretty challenging business model. It might be easier for us to license this technology. There is a pathway that we license this tech and we actually don't need to raise any more money. And that is a pathway. But there's some trade-offs. So if we go the equipment sales route, we build manufacturing facilities around the world and we start selling hundreds of these pieces of equipment. We start getting into these other markets and get revenue from selling equipment and servicing it later. Then our total revenue potential as a company is pretty large. If we go the licensing route, our operating costs are much lower. We can do that with a much smaller team, but our total revenue potential is also much lower. And so it's a good question, good considerations. We talk about all this with our investors. Right now, we're very keen on equipment sales. I'm keen on stepping up over time. So I'm on film, so I'm not going to say exactly how much we're planning on raising in the next round, but we do plan on doing another financing in about 18 months.
Does the cell have to be replaced, and if so, how often?
So this is really interesting thing about our photocatalyst is it is very stable. And so we've actually been trying to find out how long it will last. And it has been challenging. So of course it will not last forever. In our cost models, if we can get it to last 6 months, then we're okay. And whenever we do a regression on the cell life, it's looking like it could pretty easily last a year or more if we give it the right conditions. There are a couple factors that can contribute to the catalyst breakdown, and we have to control those. And so if those are adequately controlled, then the cell life should be very, very good. But once again, there's a trade-off. If we control those very, very closely, then that costs a lot of money. And if we control them less closely, it costs less money. And so there's a balance between cell life and controlling those factors where it makes the most sense. I hope that makes sense.
Where did you get the name from?
Syzygy. So don't do what I'm about to say. So me and my co-founder were sitting there drinking beer one night, and where a lot of great names come from, but we were really like scratching our heads, like, what are we going to call this company? And we started talking about astrological events and or astronomical events. And so Syzygy is the alignment of 3 planets. Anytime there is an eclipse and the sun and the moon and the earth line up, that is a syzygy. And so we started talking about it. We recognized the 3 Y's in it, and we were talking about other things that we really valued. Like we really are interested in technologies that have to do with the energy industry, technology, period, and sustainability. And we realized that each one of those words ended with Y. And we realized that syzygy was the alignment of energy and technology and sustainability, the 3 things that we really cared about. And so our company is an alignment of those 3 things. And those are kind of like the DNA, the core of who we are and what we do. And so that's where the name Syzygy comes from.
Okay, so when I asked that flow question, what I went was like for your refrigerator-sized unit.
Yeah.
Like, how much production is that unit making in a certain unit of time?
So that unit would probably be about 50 kilograms per day, and that would be enough for 20 to 30 forklifts.
Wow.
And so you put that on the back of a warehouse that has 20 or 30 forklifts, and it can provide hydrogen to them.
I have a question back here. What's your estimated cost per unit, and how does that change with scale?
Given that I'm being recorded, I'm not going to give you an actual like estimated cost per unit, but I can talk about it in terms of our competition.
Mm-hmm.
And so all in, the estimated capex for one of our units is about half of our competition. Our competition being on-site small-scale steam methane reforming or on-site electrolysis. And so we achieve that capex reduction because of the materials we're using. And so because our catalyst operates at much lower temperature, we can build our reactors out of aluminum and glass instead of having to use nickel and chrome. Per pound, the cost reduction going from like a nickel or a chrome down to an aluminum is between 10 and 100x cost reduction. And so that's where a good chunk of it comes from. Another thing, because we're using lights, you turn the lights on and the reaction starts. You turn the lights off and the reaction stops. Our competition, especially small-scale on-site steam methane reforming, it can take them between 12 and 24 hours to power their reactor up or down. It takes a very long time. So what they have to do is they have to buy these big storage tanks because you actually never ever want to shut it off. So you're producing at a constant rate, and you use the storage tank as a buffer to handle the variations in demand. And so that larger storage tank and the additional infrastructure, the compressors, and all that also helps to add in cost. And because you can just turn our unit off if you want, you eliminate a lot of those ancillary components.
What are some downsides, or not downsides, but like challenges you might like encounter like in the future with like what you're doing?
So I'd say let's split this into 2 dimensions. One is technology and one is market. And so technology challenges are abundant. You know, anytime you're taking something new out of the lab that's kind of at like the cutting edge of human knowledge, there's a lot of challenges. We've actually overcome some of the biggest ones that we're going to face already in our initial scale up. Whenever I said that we're producing about 50,000x more today than we were, 18, 24 months ago, that is huge. Going forward, now our challenges on the technical side are primarily in the engineering realm. And so whenever you're dealing with, and this gets into chemical engineering, one of the main factors is energy efficiency. And so like energy losses in the system, how do you keep the energy inside the reactor and not like escaping out into the environment? And so optimizing that energy efficiency is absolutely going to be one of our biggest challenges. Another one is on the technical side is manufacturing complexity. And so this cell-based design, you have a lot of like little gas tubes delivering gas to each cell. Each one of those requires fittings. Each one is a leak point. Like it's so easy whenever I'm sitting up here, like, oh, look at this cool PowerPoint slide, cells to reactor to reformer. But in practice, that is very challenging. It is not a simple engineering problem. And so the bulk of the money we raised is going towards those two things: improving efficiency and basically trying to modularize, reduce, and control complexity of the scale up to multi-cell and reformer. On the market side, once again, challenges also abound. No one likes to be disrupted. A lot of the big guys are now starting to watch us. They will not take kindly to us entering the market and stealing their customers. To mitigate this, we've actually chosen the hydrogen fuel cell vehicle market. That's why you hear me talking about forklifts and things like that as a first entry point, because there's a lot of white space there, like space that currently using battery forklifts can switch over to hydrogen, and so it's not an existing hydrogen customer. If you take those customers, then they don't look as badly upon you as if I try and steal like a semiconductor plant from them. Where there is challenge, though, there's opportunity. If we do start to disrupt the marketplace, and there's a good chance that one of them will just buy us.
Continuing on the fact, like on downside, so if we were to use and run as we do right now on carbon emissions and stuff, how would is there a downside on using hydrogen like so much? Is there anything like bad about that, because you are promoting?
Yeah, so you're talking about like at a global level?
Yeah. Or is it just significantly less than carbon? So
I like to think about it as a phased approach. So like, let's say there's different ways of making hydrogen. You can make it, as I mentioned, we're making it from methane and we're making it from ammonia. Those are our two feedstocks. You can also make it from water. If you're in the hydrogen space, you actually hear about water electrolysis a lot. You're just taking H2O and you're splitting it into hydrogen and oxygen. It takes a whole lot of electricity. If that electricity is coming from a coal plant, you actually end up doing a whole lot worse than if you'd gotten hydrogen from natural gas. And so the source of the feedstocks is very important. If the entire planet switched all of vehicle transportation over to hydrogen from natural gas, it would go a long way for us to meet the Paris Accord goals. And so it would be a amazing good thing. But if we all switched over to hydrogen from natural gas immediately, our emissions don't go down to zero. And so while it would be better than today, it's still not where we want to get. So when you think about like where we're going, we're comfortable starting with hydrogen from fossil natural gas, because it is better than gasoline. And if we can get people off gasoline, we're doing good. But over time, we actually want to transition off of fossil natural gas too and go to renewable natural gas. There's like more than 1 trillion cubic feet capacity for renewable natural gas. This is like methane from dairy farms. So I don't know if you guys have heard about like how much methane cow manure produces, but it is like staggering. And so now there's companies that are like capturing that and selling it. There's methane from landfills, and so these are renewable sources where if we don't catch it and use it, it will go into the atmosphere, and methane is actually worse than CO2. So over time, as these resources are developed, we want to shift and exclusively use those renewable methane resources. And so we do that, then the carbon impact is huge. And over a long time, as we start seeing renewable ammonia enter the market, shift to that, because that can be truly like carbon zero. And so today, at all costs, get people off gasoline. Tomorrow, shift to more renewable feedstocks. Over 20 years, completely get to 100% renewable feedstocks, 100% carbon neutral. That's a plan. If we do that, then there really isn't a whole lot of downside to hydrogen.
Is there any method of warning for maintenance required or inefficiency in hydrogen production?
I'll talk our system and then I'll talk industry. Our system is still very much R&D scale. We're scaling up. Like our reactor right now is a little bit bigger than a milk jug. We have it riddled with sensors. God, we have like 50 something detection points for all different kinds of stuff: temperature, pressure, gas leaks, and like absolutely, if anything starts to change in that system, we know immediately. In traditional larger systems, the answer is there should be, but many times there's not. And so like I don't know if you guys heard about a week and a day ago. Yep. And so like that was inadequate controls. And so absolutely we have to be safe. Safety is our number one core value. We are currently building out a new lab, and we are putting gas detection point sources at every single place there is a fitting or a connection that could cause a leak. If we can't do it safely, we can't do it at all. And so the answer is in our system today, yes. In the future, in our system, absolutely. For industry as a whole, there should be, but we need to make sure people follow the rules or really bad things can happen.
So just to play devil's advocate for a second, I mean, like burning hydrogen, your byproduct is water. Like that's what you get.
Yeah.
And so in water electrolysis, besides the electrolyte, all you're doing is starting with water and then turning it back into hydrogen.
Yep.
So theoretically, doesn't that make water electrolysis more of a sort of renewable loop system than because you just keep recycling the energy over and over by just adding electricity?
Correct. However, you got to look at like current state today, and current state today is the electrical grid is not renewable, and the electrolyzer guys, they love to talk about exactly what you said, but they never ever want to talk about the feedstocks that they're using for their system.
Like electrolyte?
Well, no, like the electricity, like the source of the electricity. If you don't hold them accountable and make them buy renewable electricity, then you actually don't do any good. And so if you run an electrolyzer on grid electricity here in Texas, the carbon intensity of that hydrogen is pretty much on par with gasoline. If you run it in Wyoming, where it's all coal power, it's actually more than twice as polluting as gasoline. If you run it in California, it's less, it's better, because California has really clean electricity. You run it in Washington, Washington's all like hydropower. Not DC, Washington State up by Oregon. It's like all hydropower and it's really clean. And so one thing we're looking at when we're looking at our natural gas system is like, what is the carbon intensity of the grid? And so areas where it is obviously better to use water electrolysis, we aren't going to go after those. But right now, you compare our natural gas system to an electrolyzer, there's only 3 states in the United States where the electrolyzer will be cleaner. They are Washington, Oregon, and Vermont. Go Bernie, man, he's done crazy with Vermont. They have really clean electricity. Globally, there's only a few countries like Norway and Sweden, but the vast majority of the European Union, the United States, especially in Asia and South America, their grids are not at all decarbonized, and so our system will actually be cleaner unless if you make the electrolyzer companies and hold them accountable to purchase renewable electricity. Last question.
How do you measure your key metrics?
Oh man, which key metrics?
How do you know if your business is doing as successfully as you wanted it to be? Like, whether people invest in your company?
I think for right now, our main key metric is technology development. So we talked about like energy efficiency and productivity. So like we're tracking those things very closely, and we have a plan for where we need to be pretty much every quarter through the end of 2021, and how closely are we following that plan? And it depends on the answer to that question is also the answer to how much did Trevor get yelled at in the last board meeting, and so so far we're doing good, but those metrics right there are the main ones that we measure the business on right now. There's also like a customer engagement metric, like how many people we talk to and what are we talking to them about, but that's not as important for us now, just because we're in a stage where if the technology doesn't work, our customer engagement doesn't matter anyways.
Right.
And so technology is number one. Cool.
Great.